All right, and welcome to lesson 8.4, logarithmic and exponential equations part 1. You'll notice that this corresponds in the textbook to pages 404 to 412. So if you want to look for extra examples, you can over there. So you'll notice a couple things is that when you see the word equations, that means we've got an equal sign in the middle. So what we're going to be doing when it says the word solve is find out what values of x we can have. And the simplest way, when we see that there is a log expression and another log, there's three different log expressions and they all have the same base of 2. That means that we can combine them. So there's more than one way to do this, but I think the simplest way is to take a look at the left-hand side. And we have two log expressions, and they're separated by this minus sign, so that if you recall, we can combine this together into one larger log expression, where instead of subtracting, we're going to be dividing. So the numerator will be x minus 2, and my denominator will be x, will be equal to log base 2 of 3. Now at this point we have a choice to make, and I think the easiest way is to say, kind of undo this log on both sides. So we have a log base 2 here and a log base 2, so whenever you see this pattern, where all you have is a log with the same base on both sides, we can kind of undo the log. So previously we took the log of both sides, now we're going to undo the log of both sides. So we're going to say that x minus 2 over x is equal to 3. And now at this point it's just an algebra problem, and if I want to get x by itself, probably the first thing that's easiest is to multiply both sides by x. So I get x minus 2 is equal to 3x, and then I'll subtract an x from both sides. So I get minus 2 is equal to 2x, and then I'll divide both sides by negative 2, or actually I'll divide both sides by 2 to get x by itself. So I'll have negative 1 is equal to x, or feels so much better if I say x is equal to negative 1. Now you might think that we're done at this point because we've got x equals, but there is an extra step that we need to take, and it's very important. I think important enough that we should write a little note. So let's start it off by saying note. Arguments must be positive. What do I mean by that? I don't mean that when you're fighting with a friend you should say nice things. Well, I guess that's a good rule too. But if you recall, the arguments of each of these logs, so there's three of them. I have an x minus 2, I have an x, and then I have a 3. So first of all, to say it mathematically correct would say that real answers, if I was going to solve this in the real domain, that I can't have an argument that is 0 or less than 0. So 3 is always positive, so we're good to go. So I need to check these, x minus 2 and x. So if I've substituted a negative 1 into these solutions, negative 1 minus 2 is equal to minus 3. So right away I know that I can stroke this out and I can say extraneous root. We're not testing if this will, if I get some of these that are positive, it's okay. Like here, the 3 is positive, but if any one of these arguments are negative when I put my solution in, then this root is extraneous. And now if I get more than one x value, and we'll have a couple examples like that coming up. If I get more than one examples, one of them might be extraneous, in which case we would stroke it out and the other one would still stand. So in this case, right away, we can say it's an extraneous root because when I substitute my minus 1, I get a minus 3, and if I substitute a minus 1 here too, I would get a negative as well. So my answer then would be no solution. Or I'll write it in two ways. No solution. You could also say no real roots. Okay, so those are both good ways of stating the answer. Okay. All right, let's go take a look at example number 2. There's a difference in example number 2. And the previous one, they were all log statements. So what's different about this one is that it just has a 2 by itself. So I'm going to start off just the same and say, okay, I've got two statements on the left-hand side, two expressions, pardon me, each with a log base 4. So I can combine those together. Since they're being separated by the plus sign, since it is a sum, when I put them under one log, I'm going to use a square bracket just to keep track of everything. I'm going to be multiplying. So I'll go 11 minus x multiplied by x plus 6 is equal to 2. Now, it's not like I can undo a log on both sides like my previous question, but what I'm going to do on this one is convert it to exponential form. So convert to exponential form. If I could spell, that'd be great. So those are our two strategies for this entire section here. The one is what we did here was get rid of the log on both sides. So if you have this pattern where all you have on the left is a log of some expression is equal to the log with the same base of some expression, we undo the log, so to speak. Okay, so that's one way to do it. And the other way to do it here is convert to exponential form. So you're going to be looking for one of those two methods in each of our questions. So how does that work? Well, the base is 4, so I say 4 to the power of 2 is equal to this argument, 11 minus x multiplied by x plus 6. Alright, so now we just do some math here. So 4 squared is 16. It's going to be equal to, now when I multiply this out, I'll use FOIL. So first I get 11 times x, so it's 11x. Outer, 11 times 6, so that's plus 66. Inner, negative x times positive x is negative x squared. And then last I get negative x plus 6, so I get negative 6x. Alright, I think I'd feel more comfortable if this was positive, the x squared was positive. So what I'm going to do is I'm going to put everything on the left hand side. So I'm going to add x squared to both sides. And so I've taken care of this one. Looking at these two, I've got an 11x minus a 6x. So on the right hand side, that's equal to 5x. And when I subtract it from both sides, I'm going to get minus 5x. I hope I didn't do too much of that all at once there. And now I have a plus 66, so I'm going to subtract 66. And I still have my plus 16 equals 0. So I did a couple things all at once there. Maybe that was unwise, but sometimes I get tired of writing all with this pen. So these two terms I can combine together. So I get minus 5x minus, what does that work out to? 50 equals 0. Okay, so now I need two numbers that multiply out, two different numbers that multiply out to negative 50, and two different numbers that add up to negative 5. So what could those be? So I could get a 10 and a 5 would work here, I'm thinking. 10 and a 5. And which one should be negative? I think the 10 should be negative and the 5 should be positive in order for it to work out. So I will go and say, okay, here, x minus 10 times x plus 5 is equal to 0. So yeah, that will work out. So my two solutions here at this point will be x is equal to negative 5 and x is equal to 10. Now I need to check to see whether or not these are extraneous or not. So let's go back to the very beginning, and I have an 11 minus x and I have an x plus 6. If I use my x equals minus 5 first of all, let's just think. If I take my 11 minus x and I put a minus 5 into there, then 11 plus 5 is equal to 16. That's okay. And if I take my minus 5 and I plug it into x plus 6, then I get a 1. So that's okay too, because remember they have to be positive. So my x equals minus 5 is good to go. Okay, now let's check my x equals 10. If I put my 10 in there, 11 minus 10 is 1. 10 plus 6 is 16, so it's both positive. So they both look good. So these are both good answers. Okay, so let's go on to our next question here. Oh my, it's a your turn. So I will pause for a little while. I'd like you to pause the video and try this one. I'm going to give you just a tiny little hint here. First of all, a couple of hints maybe to help you. It doesn't say what kind of log it is, so this is going to be a log base 10. And do you remember that if this is multiplying times 2, when you put it inside the log, it's going to be squared. Alright, so give it a pause and try it out. Alright, I'll solve the first one for you, and then I don't know if you did both of them or just tried the first one. I hope it went alright. So my hint was about this log business here with the 2, so it's going to look like log. I'm not going to write the 10s for now. I'll just, if it comes to writing the 10s at the end, I'll do it. So x squared minus log of x plus 2 is equal to the log of 2x minus 3. Now we're not quite at the stage yet where we just have a log of something equals the log of something, so we can't undo things yet. So what we need to do is we need to combine these two terms together. So since they're separated by a minus, we will be subtracting. So I'm going to go log, and I'm going to do a nice big square bracket here just so I've got room. My x squared will be in the numerator, and because this is subtracting, it'll be in the denominator. X plus 2 is equal to the log of 2x minus 3, and I'll put parentheses around that. Okay, so now I can do my undo the log of both sides trick. So I'm going to get x squared all over x plus 2 is equal to 2x minus 3. At this point, it's all about the math. So what I have to do is multiply both sides by x plus 2. That denominator kind of bugs me, so I'm going to multiply both sides by x plus 2. So here I'll even go through all the effort here. So when I multiply this side by plus times x plus 2, that cancels out, and then I multiply this side but times x plus 2. So I will get x squared on the left is equal to, now when I multiply those two binomials out, I'll use FOIL, so I get 2x squared for my first, and then my outer I get plus 4x, and then my inner I get minus 3x, and then minus 6. So right away I'm looking at those linear terms, and the 4x minus 3x, I'm going to get just an x. I'm also going to subtract an x squared from both sides. Okay, and now when I factor that, I will get an x minus 2x plus 3. So my two answers will be x equals plus 2 and x is equal to minus 3. Now let's go check. Plus 2 will work here, plus 2 will work here, and plus 2, 2 times 2 is 4, 4 minus 1. So the plus 2 one works, so that one's good. Now the minus 3 won't work, so I don't even have to check anymore. If it doesn't work for one of them, it just doesn't count. So I'll put a stroke through there, and I'll say extraneous. Okay, so I do need to show my x equals minus 3 and then show that I've rejected it. Okay. All right, so there's a second your turn. I mean, it is your turn. And again, I'll wait for a little while, and I'd like you to pause and give this one a shot. Alright, when we take a look at this one, you'll notice that I don't have all log expressions. I have a non-log term in here. So what I'm going to do is I'm going to get all the logs to one side. So I'm going to say log base 6 of x plus 3. I want to get this one to the other side, so I'm going to add it to both sides, plus log base 6 of x plus 4 is equal to 1. Now I need to combine my two log terms on the left hand side, and since they're both positive, they're adding together. When I combine them together, they will be multiplying. So I'll get an x plus 3 multiplied by an x plus 4 is equal to 1. I can multiply them together now, or I can just wait. You know what, I think I'll do the convert to exponential form first. So my base is a 6, so 6 to the power of 1 is equal to, and you know what, I may as well multiply them out now since I've got to rewrite it anyway, so it's going to be x squared plus 7x plus 12. Now 6 to the power of 1 is just equal to 6. I need to solve this. I'll make the left hand side equal to 0, so I'll subtract 6 from both sides. So I get 0 is equal to x squared plus 7x plus 6. So just as a reminder, what I did to both sides is I said I'm going to subtract 6 from both sides, and that's how I got that. Now I need to factor another time, so I will get 0 is equal to I need two numbers that multiply out to 6 and add up to 7. So I think a 6 and a 1 will work. So my solutions, my roots will be x equals -1 and x is equal to -6. So going back to my original one, if I put a -1 here, -1 plus 3 is still positive. -1 plus 4 is still positive, so that's a good answer. When I put a negative 6 in, negative 6 plus 3 does not work. So this one I will reject, and I will say that it is extraneous. Okay, I hope you did well on that. Moving on to our next section, solving exponential equations with different bases. Okay, we've been looking forward to this one for a while. So you may remember that we did something like this in the past, but it was estimate. So it was like plug it into your calculator a few times until you get a nice one. And I'm sure we were all a little uncomfortable with, plugging in 3 to the power of 1.8, 3 to the power of 1.9, which one's closer. So it is a math class after all. The guess and check method is sort of like when you don't know how to actually do it. So let's do it. So the first stage here is to take the log of both sides. So we have 3 to the power of x is equal to 8. So we're going to apply a log. We're going to take the log of both sides. Again, we're following that golden mathematical rule. As long as we're doing the same thing mathematically to both sides, this equal sign will still be true. Okay, so now this next statement comes into play. This will allow the exponent to drop down in front of the log and become accessible. So here's what we mean by that. This is inside the log, this is 3 to the power of x. So now if I rewrite this, I can say x times log to the log base 10 of 3 is equal to the log of 8. Okay, so that's what we mean about this drop-down feature, and it's kind of the opposite of what we just did in a previous question. And now we're so close, all we need to do is divide both sides by log of 3. So I say x is equal to the log of 8 divided by the log of 3. Now, because they didn't say what the base is here, it's 10. And that's nice because we can just type that into your calculator. So I do want you to practice doing it in your calculator because all the different calculators are different. It doesn't say how many decimals. So let's assume that it's going to be to 3 decimal places. So we can say 1.89, and then it's 27. So I'll say 3. Okay, because I think it was 1.89279, something like that. You can leave extra decimals. Okay, even if it says, due to the 3 decimals, you can do extra. This would be correct, and if you do this, this would also be correct. One thing I should tell you is when you're doing your calculations, I say this in all my classes, the science classes as well as the math, if you have a series of calculations to do, only round off at the very end. So in this case, of course, there was no other opportunity to round off earlier, but keep all the decimals, learn to use the memory in your calculator, and then if you're asked to round off, only round off at the very end. So that's how you do that question. Let's take a look here. Scrolling, find something else here. Okay. Example number 2. Solve the following equation below. Express the answer. Okay, now we're told 3 decimal places. All right, well, let's start off just like we did before. And we're going to take the log of both sides. So I'll be thorough here, and I'll write it out. And it's the log of 19 to the power of x minus 5 is equal to the log of 3 to the power of 2x plus 1. And now, just like in the previous question, this x minus 5, because it's a power, is going to be multiplying when it's outside the log. Now, be very careful to make sure you put parentheses around that x minus 5. Because the entire term x minus 5 is multiplying. Clearly, if you didn't put that, right? If you didn't put that, more is disappearing than I wanted there. If you didn't put this, and I'm being a little careful here because this is incorrect. This would look like x minus 5 times this, and it should be the entire x minus 5 multiplied by that log of 19 is equal to, on the other side, similarly, 2x plus 1 multiply times the log of 3. Okay, so now it might be tempting at this point to divide both sides by the log of 19 and then to sort of get the x's on one side and the logs on the other side by multiplying and dividing, because that's what we've done before. In fact, I'll do that step once and then I'm going to erase it. So if you're doing this at home, you don't need to do this step. So if I was to divide both sides by 2x plus 1 and then divide both sides by the log of 19, it's kind of a dead end. It's not easy to do. It's not easy to solve for logs on both sides. So I would, avoid this. Okay, instead of that, and sometimes I hesitate to show you the wrong step because it gets in your head. Here's what I want you to do, and it seems like more work, but I want you to multiply this all out. You know what? I'll just see if I can erase this. I'm going to try to use my magical powers here. Oh, semi-magical powers. Okay, let's try it again. Oh, very nice. Okay, so we'll try over here now. Let's multiply this out. So my x minus 5 is going to be x times the log of 19 minus 5 times the log of 19 is equal to, now multiplying on this side is going to be 2x times the log of 3 plus 1 times the log of 3. So I'm just going to write the log of 3. Now we're closer. So now we're going to get the terms that have x's on one side. So maybe what I'll do is I'll put all the x's on the left hand side. So I'll keep this one here. I'll have x times the log of 19, and then I'll subtract this from both sides. So I get minus 2x times the log of 3, and I'll add this to both sides. So I'll have 5 times the log of 19 plus the log of 3. Okay, now we're getting very close, and this last step is we're going to factor out this common x. Okay, so if I put an x first and then a left parenthesis, that's what I mean by factor out. Pull out an x is another way of saying it. So I'm going to get a log of 19 here minus 2 times the log of 3 is equal to 5 times the log of 19 plus the log of 3. And I hope you can see my last step here. I need to get x by itself, so I'm going to divide both sides by what's inside the parentheses over there. So in fact, I'll write it on the same line. Log 19 minus 2 log of 3, and I'll write the whole thing again. Log 19 minus the 2 times the log of 3. So this part here cancels out and becomes 1. So I get my answer. So I get x equals. And I want you to try this on your calculator. And you might have to be careful about the denominator. Whenever we have multiple terms in the denominator, so you could say 5 times the log of 19 plus the log of 3 equals left parentheses, and you're going to have different strategies, but mathematically I'm going to put those parentheses in there because that's the thing to watch out for. You don't want to just be dividing by log of 19 and then have this outside of the entire fraction. So that said, when I do my calculator work and I want it to 3 decimal places, 21.173. Okay, so here are the 3 decimal places. These don't count as decimals. Okay, so 21.173 would be your answer. And again, please get your calculator out and try it out just so you get the practice. Last one in our lesson. Okay, 2 times 3 to the power of x is equal to 6 times, or 6 to the power of 3x minus 1. And this is an excellent note to have here, that you cannot just on the left hand side say 2 times 3 is 6, so therefore this is the same thing as 6 to the power of x. Okay, so this is 2 multiplied by itself once, and then 3 multiplied by itself x times. So you can't combine those. What you can do is if you had 3 to the power of 1 multiplied by 3 to the power of x, that would be equal to 3 to the power of 1 plus x. So you can do stuff like that. Okay, so what are we going to do? We're going to use the same method we did before. We're going to take the log of both sides. Okay, so if I say I'll have the log of this whole business, 2 times 3 to the power of x is equal to the log of 6 to the power of 3x minus 1. I'll even put some parentheses around that. Okay, so now I'm gonna expand this as much as I can. So inside of here I've got a 2 multiplying. So when I write separate logs, that's going to turn into adding. So I'm going to say log of 2 plus, all right? So because this 2 is multiplying with the 3, that's why we get the plus. Now 3 is to the power of x, so when we separate that log 3, it'll be multiplying times x. Okay, so hopefully that, because we've done this kind of stuff previous, hopefully from here to here is okay. We've kind of more practiced the other direction, haven't we? So now, over here, very similarly, I'm going to get 3x minus 1 all multiplied by the log of 6. Okay, so we're getting quite close to what we had, no, quite close to the kind of question we just did. So now I need to multiply this out. Okay, so the left-hand side will stay the same. Log of 2 plus x times the log of 3 equals, now when I multiply this out, I will get 3x times the log of 6 minus 1 times the log of 6. So I'll just write the log of 6. Now I want to get my x's together. I've got an x log of 3 here and a 3x here. So maybe what I'll do is subtract x log 3 from both sides and add log 6. So I'll get log base 2 plus the log of 6 is equal to 3x times the log of 6 minus x times the log of 3. All right. On the right hand side now, I factor out my x. 3 times the log of 6 minus the log of 3 is equal to, I just have to rewrite this, log of 2 plus the log of 6. And now I'm going to get x by itself by dividing. And so I just need to keep writing this out. And this part here, that cancels out to 1. So on the right hand side I just get x. And then on the left hand side, getting my calculator out again and doing all that work, now I get an answer of x is equal to 0.581. 3 decimal places. All right, and here is your homework from page 412. 1 through 6, 7, A and D, 8, A and B, 20B, and then from the C section 1 and also part B of number 4. Good luck with that, and we will see you in class.